let's look at the graph of sine now. I promise this one will be shorter because pretty much all of those ideas are going to be the same as applied to sine instead. So as we previously noted, sine starts at 0 because when I'm looking at my t value, sine of t always returns the y coordinate, as was our unit circle definition. Then when we move to, say, pi over 2 up here, sine will return the y value, which is 1. Go ahead and note that. When I get to pi, sine will return 0. When I get to 3 pi over 2, sine will give -1. And when I come back to the start, I will go back to 0. And those gives us our key outlining points, which is a good place to start. Sine starts at 0, maxes at 1 when you plug in pi over 2. When you plug in pi, it returns back down to 0. And again, let's label this with 1 and -1 as before. Then when we get to 3 pi over 2, goes down to 0. And then to 2 pi, we get that sine goes back to 0. And it has the same exact pattern, just it starts at 0 instead of 1. So how you could think of it is cosine starts at 1, immediately goes downward into the wave to its min, comes back up, whereas sine starts in the middle, goes up, down, all the way down, and back to the middle. Sometimes the middle of the wave is called the equilibrium point, and the height of it is called the amplitude. And the period, which is the distance that it takes to complete the entire wave and return back, like from wave tip to wave tip, is referred to as the period, the length of one cycle, or the cyclic pattern behind the graph. Which it's kind of obvious why sine and cosine have a period of 2 pi. It's because that's the circumference of the unit circle. And since the functions are defined by the unit circle, it makes sense that it would take 2 pi to return to the same point, and then it will just cycle. One thing I forgot to mention in the previous video was that this is not the complete graph of cosine, but this is just what we often refer to as the graph of one period or one cycle. Because really what will happen is as you continue moving along the wave, it will keep going, and because as you move along the unit circle, there's no stopping it. Like there's no reason that it has to just be fixated from 0 to 2 pi, because the point can keep going. As we discussed with coterminal points, if you add 2 pi, it will be the same. And so you can continuously add 2 pi, and it will just keep cycling and repeating as the period progresses. So I'm sure we'll discuss that more later, but let's get back to sine, because otherwise sine is exactly the same. And if we let's also look at the intermediate points between those key points, as I did before, just to make sure. But it is the exact same pattern, because if we look at sine starts at 0, then it goes up to 1/2 at pi over 6. So at pi over 6, which is the first tick mark, we go up to exactly 1/2. Then root 2 over 2, 0.7. Then root 3 over 2, 0.87. So in the middle is pi over 4, and at the top is sine of pi over 3. And basically it will follow along. It has the same curvature, exactly the same as cosine. And instead of graphing the rest of the points, since that is quite tedious, let's just, and this is what most people will do when they're graphing trigonometric functions. They won't actually graph every single point because it's really, really tedious. So, but the whole point of this long-winded video is just to help see the shape. Why does it have its curvature? And what do those really look like? So it's a very smooth, like polynomials, sine and cosine are smooth and continuous functions. They don't have any sharpness to them, which is important towards differentiability in calculus. But yeah. And the key thing to differentiate the two graphs, because they really are the same curve, is that cosine starts at 1, sine starts at 0 as well. And the last thing for this video is what we refer to as the periodic nature of sine and cosine. But this is something that when we talked about coterminal points, we discussed this. But this, just to summarize, the period of sine and cosine this is often referred to as the baseline period because you can change this by doing a horizontal stretch. Like if we compress the graph or stretch it this way, it will change that period. But it's important to note that the baseline period of sine and cosine is 2 pi always, which all that means is that if you take a value and add 2 pi, it's the same as if you were to just take the sine of that value because both t and t plus 2 pi are coterminal, because all you're doing is you're taking the terminal point, adding 2 pi, going one full circle, coming back to the start.